Where did the first black holes come from? In a previous video, I explained how the normal way that black holes occur, with stars larger than 20 times the mass of our sun collapsing, is insufficient to explain these early black holes. In this video, I'm going to tell you 3 ideas for how those black holes may have appeared. Let's jump into it. The first idea is a relatively esoteric one. You might remember how in the early universe, during the inflationary epoch, there were quantum fluctuations that seeded the structure of the universe. These quantum fluctuations created slightly different densities from region to region. But there are some scientists who've asked the question, and indeed hypothesized, that perhaps during this era, some of these quantum fluctuations were sufficiently dense that they collapsed into black holes, and perhaps those black holes are part of the story of these monster black holes that we see later. And I say part of the story because even this suggestion of quantum fluctuations collapsing into black holes, it's theorized that such black holes would have only initially weighed between 10 to a couple of hundred solar masses. And even with mergers and collisions ever since, that doesn't come close to explaining the monster black holes that we see in the 600-700 million year universe. Because of that, let's take a look at the second idea. The second idea looks at that time period when the primordial large gas clouds were breaking up and creating stars in little pockets. And the idea goes like this. Maybe some of those monster hydrogen-helium clouds that broke up and then had those broken parts compactify into stars, maybe those initial monster gas clouds, maybe there's a way to stop them from breaking up and collapsing into stars and have them collapse directly into a black hole. And that's where this idea gets its name, DCBH, direct collapse black hole. How would these gas clouds have avoided the normal breakup and compactification? The theory over there is that these gas clouds were in a region of space that was adjacent to a region of space that had stars that had been born there, and the radiation from those stars in the neighboring region came into this region, and it broke up all of the molecular hydrogen, the H2 molecules, that made up a large portion of this cloud. The thing is that in order to have this humongous gas cloud break up and clump up in a bunch of different regions, you need it to be able to cool down. You can see my video on the creation of the first stars to better understand that. You need this cooling, and H2 molecules emit radiation that is cool a gas a lot better than lone hydrogen atoms. And what happens is the neighboring region with its starlight emits radiation that breaks up the H2 molecules in this region, and that leaves lone hydrogen, which can't cool fast enough so that parts of the humongous cloud can break up and compactify individually, and instead the entire cloud enters into a collapse, which results in a black hole. These black holes would have formed around the age of the first stars, and by the 750 million year universe, these black holes would have grown to somewhere between 1 billion and 10 billion solar masses. And that hits the nail right on the head with these monster black holes that we're seeing in the early universe. So this second explanation of direct collapse black holes, if it turns out to be true, could actually account for these early quasars.